Okay, hello Chem AP students. I'm Mr. Hevel,
And Mr. Moore.
and today we're here so that we can videotape your first lab. Okay, but we got to give you some background so you have an idea what's going on. So, I believe this reaction that you're going to use involves a double replacement reaction.
Double replacement reaction. You remember what that is?
If you don't, go look it up. Okay, and because we're going to make a precipitate for this reaction, we can capture the precipitate on a piece of filter paper. All right, and we have to show you a new lab technique that we use to help that along. Okay, so the College Board would refer to this as gravitometric analysis. Okay, we're going to use the mass of the precipitate to help us calculate something.
Sounds good. Yep. So what kind of equipment do we have for gravimetric analysis?
Yeah.
We have one of these. A normal flask is not quite normal. It has this sidearm on it. So you can, we'll do something with that. There's going to be a funnel that has a stopper that it's going through so that we can make a good seal between the funnel and the inside of the flask.
And we have a piece of filter paper, again, that will be in the funnel to capture our precipitate. And if we did this using gravity to pull the water through, it would take a long time. And Mr. Moore has a lot of patience. I couldn't wait that long. So we're going to use something called suction filtration.
Yep.
And I don't know if they can see it because we're a long ways away.
Yeah.
On the faucet, there's a device called an aspirator. And it's what's going to generate the suction force. So let me just show you real quick what's going on there. So if we turn the water on, the water rushes through the nozzle, but it pulls air through this sidearm. And you can tell that because when I plug it up, the water slows down. Okay? So the idea is we're going to hook this heavy-walled vacuum tubing up to this sidearm, and we'll connect it to the flask.
So that creates a vacuum? That's pretty cool.
Yeah, here, we'll check it out. Here, let me take the funnel off for a second.
Yep.
If I turn the aspirator on, put my hand over it.
I can hear it. Yeah. Oh, how nice.
Yeah, you hear the popping noise? Yeah. So we can generate vacuum, and that will help draw the water through so we don't have to wait as long.
Doesn't that waste a lot of water, Mr. Hevel? What about the fishies?
Well, you know, it all goes back to the same place. It's going to go down the drain
Oh, okay.
and go out to the lake.
Okay. All right.
And chemistry is more important than anything. So
Absolutely it is.
the fish will figure it out. Okay. So let's show you what a difference it makes, though. And I wish you were here live to be able to do this, but we have to put the piece of filter paper in the funnel and get it to seal tightly. And so we'll fold it in half once, fold it in half twice, and if we pull 3 of the 4 edges together, we get a nice cone shape, and that'll fit inside that funnel tightly. So normally what I do,
We use a little water to help
go.
that stick. We wish you were here for
Yeah.
this. You need to be doing all this yourself.
yeah. So usually I soak the filter paper down and I press it tightly into the funnel. We want a good seal. We don't want any air rushing behind the filter paper because then we lose suction power. So if I put some water in here, okay, I don't know if you can see this. The water dripping through. I don't know how well it's showing up. If I put my hand back there. Can you see the water drips coming through? Notice the rate they come through. It's not real quick, and once you get precipitate on the paper, it starts to plug it up, which slows it way down. But now watch, I'll turn on the vacuum.
Wow,
And all of a sudden, pow, the water just gets pulled right through. Okay, it speeds things up quite a bit. Okay, so that's suction filtration. We're using this technique to help us capture the precipitate that the reaction generates.
And it goes a lot faster with the suction.
Yeah.
We can't stress that enough. We would be
Yes.
sitting here for a
For a
long time. Yep.
Yes, it would not be good. Okay. So let us tell you some more information. What, did we forget anything there?
I think, no, that's going to get us our precipitate, and we'll filter everything that's dissolved right through the paper. The paper
Yes.
only catches the solid
I did say that.
precipitate, and everything else goes through.
Right, anything that's aqueous runs through the paper.
Yep.
Yep.
So should we talk
Yeah.
about the specific lab?
Yeah.
All right.
You want to stand or you're just gonna?
No, I'm just going to hold it.
Okay, so there's a little bit of information you need. Last year, we used solubility a little bit, but it's important to know this. These ions are always soluble. Group 1 metals, the ammonium ion, and the nitrate ion. You need to know that, okay? Here's what you're going to get. You'll see this in a minute. We mixed 2 ionic compounds together. There's potassium chromate and barium chloride, right? They're both solids. We mixed them together to create the sample, okay? Another very important item to know is that potassium ions, barium ions, and chloride ions are all colorless in solution. But the chromate ion looks yellow. It's a very noticeable yellow color if it's present in solution. Okay? So what's going to happen here, and you'll see this in a minute, we have a sample that has these 2 solids on a piece of paper. Okay? Essentially, we're going to dissolve it in some water. The double replacement reaction will happen. A precipitate will form. And then we're going to filter out that precipitate. Okay?
Yeah, double replacement, remember, the positive ions switch places.
Something like that. I get confused.
Yeah.
Yeah.
I'm just trying to work that out in my head.
Yeah. I mean, you haven't done this in a year, so.
It's been a long
I
time.
forget,
Yeah. Okay. So that's what we're up to. Let's see. There's already a sample that has been measured out
Yes,
and
there
waiting
is.
for us.
Yep. Normally, if you were here, you would get every lab group would get his very own sample to use. And so, Mr. Moore and I are the lab group now.
We'll see how we can botch this up
Yeah.
for you.
Oh, and we will. Okay. So here's the sample. I don't know how well it shows up at all. Not this way. So on the piece of paper.
Yeah, you know what? I can tilt this down. See it.
Yeah. I think, oh, now we have a ton of glare. You
Okay.
can't see anything, I don't think.
Ah,
Okay.
there it is.
There
There's
you
the
go.
sample.
Okay, there's the sample. Okay, again, it's the potassium chromate and barium chloride mixed together on this piece of paper. Okay? Now, it's probably important for us to know the mass of this sample to start with.
Yeah, we
Okay?
probably ought to know that.
Probably ought to know that. So we got a balance here, a scale.
We're going to dissolve that sample in water, so we'll use a beaker. We'll put the beaker on the balance.
Should we move it over
Yep,
closer?
I'll bring it over.
I can move this.
That's all right. Well, I'll need to pick this up to be able to see the mass on there.
Oh, I guess so. Okay, so here's the beaker.
Yep.
You
That
use
mass doesn't matter so much. We'll just zero out the balance.
Okay. Okay, now I'm going to dump the sample in.
Okay,
There's our
there's-
sample mass.
Yep.
Okay, now we need to get this to dissolve. Okay, so I'm going to put a little water in the beaker, swirl it around for a minute or so. Now, the exact amount of water that we use doesn't matter. Okay, I certainly didn't try to measure it, and it doesn't matter at all. But now we've had the reaction happen. You may notice that it's cloudy. You can't see through it, so there definitely is a precipitate in there.
Yep.
So now gravimetric analysis means, right, we're going to try to capture that precipitate and use its mass to help us with our calculation in the future.
Okay, I try to get this camera onto the
Yeah.
suction filtration. Looks like it's there.
Yep. I wonder, Mr. Moore, do you think the mass of the filter paper matters?
We probably ought to have it.
Okay. We'll play it safe. Oops, hold on, I forgot to zero the balance.
Oh, yeah.
See, I'm already goofing up here. Okay.
There.
Here we go. There's the mass of the filter paper. Okay, now I gotta fold it again real quick, so hold on. Okay, get it in the funnel. Wet the funnel. Filter paper. Okay. Turn on the suction. Now you do have to be careful. If you were here, I'd caution you to not turn the water up full blast because some of the aspirators actually will rip the filter paper because it generates so much.
Yeah, that happens quite a bit, really.
It does.
So now we'll...
So now here we go. We're going to start the filter. Oh shoot, Mr. Moore, look. Does that look cloudy to you? What you don't want to see is cloudiness down here. This liquid down here is called the filtrate. And it should be clear. It may have color, but it should be clear.
I don't think that looks too bad.
Okay.
I think we're good with that.
I was worried that there was a gap
Yeah,
up
I know
here.
what you mean.
Okay, now you see how it's slowing down already because the pores in the paper get plugged up. I'm going to turn the water up a little bit more. Sometimes this takes the entire hour to filter this, or close to.
Yeah, all that mixture that's in that beaker needs to run through the filter paper.
Yes.
The solid will get caught, and all the liquid and the dissolved ions will run through it. So it's just the precipitate that's going to wind up there in the funnel.
Yep. And we have a couple tools. Of course, we have our wash bottle. This comes in handy because we can rinse the beaker.
Yep.
We want all that precipitate in there. And, excuse me, we have one of our stirring rods here with a rubber tip. It's got kind of a funny name. Who thought this up?
I'll never understand it.
Yep, it's called a rubber policeman. I don't get it.
Yeah, you heard it right, a rubber policeman.
Yeah.
Okay, so at this point, I think we can go ahead and turn the camera off.
Yep.
We'll finish filtering, and then what do we have to do? We have to wait until not only is all the water and the ions out of it, the dissolved ions, we'll have to wait for it to completely dry.
Yes.
And then we can get the mass of the precipitate that was caught on the filter paper.
So we're doing this on a Friday afternoon, which is perfect because we can let it dry over the weekend.
Yep.
And we can come in on Monday and measure this mass for you.
Here we're finishing off the last little bit of the trying to filter the precipitate out. You see Mr. Hevel's using that rubber policeman to scrape as much of that solid out as we can get.
I used the wash bottle to wash the beaker a little bit.
It is a precipitate, so it's insoluble, does not wash out very well. Doesn't wash out at all. So we really have to work at it to try to get it all out.
Right.
We want to make sure that we don't. That glare is terrible. We don't want that liquid to be up over the filter paper that's in there either. Sometimes we'll see students do that. They'll pour the liquid in all the way to the top of the funnel. Some of the precipitate then will run down behind the filter paper. So we're trying to be careful not to do that. It's still dripping through. It's going slowly now because even though it's got suction on it, a lot of those pores in the filter paper are clogged up now with precipitate. Yep. So here's our sample. 3 days later, we've given it a chance to dry. I don't want to mess with it too much because I don't want any to fall out before I take the mass of it, but that's what the precipitate looks like. And we're going to take that, doesn't have to be flattened out. I'll put it on the balance. The balance right now reads 0. There's our final mass of filter paper with precipitate.